Hello Year 10, it's Miss Bailey here. Today we're going to be looking at titrations. Your first activity is to watch the video that is hyperlinked on the Padlet so that you can have a look at a titration being carried out practically. So from the video, can you recall what the purpose of titrations are? So pause the video whilst you complete the gaps here. And so what you will have seen there is some new equipment. So 3 in particular, a pipette filler, a pipette and a burette. So we're going to look at these in a bit more depth. So a pipette is used to measure a fixed volume. So you can see at the top here, there is a faint line around that point of the glass. And so that line is telling us that once filled with liquid to that line, that there is 25 millilitres in that pipette. At the top of the pipette, it will also tell you how much it holds. This image is a bit clearer, so you can see that line there telling you when the volume gets to that line, it will be 25 millilitres. You can also see the uncertainty here in this piece of equipment, so that's telling us how accurate that 25 millilitre measurement is, and this is plus or minus 0.06 millilitres. So that means that when we are reading it at that line, it could be 25.06 millilitres, or it could be as high as 25.06 millilitres, or as low as 24.94 millilitres. So a pipette filler is used to fill the pipette. Now, in the video you might have seen a different type of pipette filler where it's more rectangular and there is a roller to take up the liquid. But these are the ones that we would use more in the classroom. So you can't really see the letters on this, but there are 3 letters on this piece of equipment. So at the top there is an A, in the middle there is an S, and on the side there is an E. So the A stands for the air valve, and this is for us to get rid of any air from within the bulb. So the way we do that is we pinch where A is and then squeeze the bulb at the same time, and that evacuates the air from within the bulb. So that's the ball part there. And then RS is the suction valve, so this is what's used to draw up the liquid into the pipette. And so we do this by squeezing the yes button. And then E is our empty valve, so this is where we can empty the pipette of the liquid into the vessel where we want that precisely measured volume to be going. And then another piece of equipment that we looked at is a burette. And so this is to add small measured volumes. So again, we've got scales that we can read and it will tell us the uncertainty at the top. But the crucial point with this burette is that because of this tap, we are adding this liquid directly to our reaction mixture. And so with our burette, it's important to note that we are adding this measured volume. So where our pipette was just used to measure a fixed volume, our burette is adding at the same time as measuring that volume. And so with our tap, if it's vertical, then that tells us it's open and the liquid will flow through. Whereas when the tap is horizontal, that liquid will not flow through as that tap is closed. So what I'd like you to do now is pause the video and complete this table, naming the equipment and also giving its purpose. So what we're going to take a look at now is how we can read a burette. So our scale of a burette typically goes from 0 at the top down to 50 at the bottom, as our scale increases going downwards. So you can see the way in which liquids sit in this container. There's a curve to it, and we call this curve a meniscus. And when we read our reading, we want to be reading the bottom of the meniscus. So this is where that cyan line has been drawn. And so then looking at our scale, we can see it's sat between 5 and 6. So between 5 and 6, we have smaller lines, and they are going at a tenth. So this is 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, and then this one is at 5.7, 5.8, 5.9, and then this larger line 6.0. With this piece of equipment, we can see whether the bottom of the meniscus is directly on that line, or we could be able to tell whether it's sitting between those two lines. So we should be giving our readings to 2 decimal places. So in this case, it's sitting exactly on that line, so 5.70. But there will be some examples on the following slide where actually the meniscus is sat between certain values. So here are 3 for you to have a go at. So pause the video whilst you have a go at these. Okay, so you also have this diagram on your worksheet. If you don't have access to the worksheet, then you can copy it into your book. How many of these pieces of equipment can you label? Pause the video whilst you have a go. So this piece of equipment here should be very familiar to you, and that is a retort stand. And attached to that retort stand is a boss and a clamp. And that's what helps hold our pieces of equipment in place. Now, sitting on the retort stand is a white tile, and this is to allow us to see any indicator change much clearer. This piece of glassware is a conical flask, and a way to remember this type of flask is that it's cone shaped, and that's where that conical name comes from, is the cone shape to it. Now we use conical flasks because of their sloped sides and the narrow top, and that means that when we're swirling the flask, we're not going to risk splashing it like we might with a beaker. In this conical flask, we're going to have either an acid or an alkali, but with an indicator. So a solution with an indicator. We've then got our burette here, and this is the tap of the burette. And within the burette, we're going to have the other solution, acid or alkali, depending on how we're setting up this apparatus. So this is an example of a table of results. Now, I always instruct students to leave space for more rows, because we keep carrying out this experiment until we get results that are within 0.1 centimetre cubed of each other. And this is what we call concordant results. But we don't know how many takes that's going to take you, and so leaving space for more rows is always really important. So what we do is we take an initial reading from our burette. So at the very start it might be 0.00, but maybe we didn't get it exactly to 0.00, maybe we started at 1.00. And we'll then take an end volume when our indicator tells us we've reached the end point of this neutralisation. So let's say, for example, that this is 24.00. What we can then do is we can calculate our titer, and this is the amount of volume that it took for this neutralisation to happen. And the way we calculate that is doing our end volume minus our start volume, so 23.00 in this case. And note, we are keeping to 2 decimal places for each of these readings, as it's important to maintain that consistency, where in other readings we might have used those 2 decimal places to go to say 0.5. But we must be consistent in our tables. And what we can then do is, with our titer values, we use our concordant results. So let's say we had another titer at 23.05 and another one at 22.95 and then 25.00 and 23.15. So of these results, we need to look at the results that are within 0.1 centimetre cubed of each other. And so here there are 3 results that are within 0.1 centimetre cubed of each other, and therefore we're going to use these 3 to calculate our mean average. And so to do our average, we would do 23.00 plus 23.05 plus 22.95, so only those 3 results that are concordant with each other, and then dividing by the number of results, so in this case that's 3, in order to get our mean average, which in this case comes out to be 23.00 centimetre cubed. So whenever we do our mean average, we only use those concordant results. So here are 3 for you to have a go at. So identify what the concordant results are and then calculate the mean average for this. So pause the video whilst you have a go. Okay, and then this next activity, you've been asked to calculate the titer first, so doing our end volume minus our start volume, and then analyse those titers to identify the concordant titers and use those to calculate the mean average. So pause the video whilst you have a go at this. Next, we're going to be considering the titration method. So can you pause the video whilst you fill in the gaps, thinking about the different pieces of equipment and the different processes which you do during this titration. Okay, so we're going to be filling the burette with acid and then using a pipette to measure 25 centimetre cubed of alkali into the conical flask. We needed to know it was that way around because the pipette is used to measure that fixed volume, whereas we haven't given a fixed volume for our acid because that's what we're going to be adding as our titration is being carried out. We're then going to be adding an indicator to the alkali because the alkali is what's in the conical flask, and we need that indicator to identify our endpoint. We then take an initial reading on the burette, so seeing where our starting level of acid is. We're then adding the acid to the alkali whilst swirling the conical flask, and that swirling is important so that it's evenly distributed throughout the mixture. Then stopping adding the acid when the indicator colour changes, recording the final reading on the burette. That is our rough titration. We then repeat the titration, but this time adding it dropwise nearer the end point. This is so that we can get a more accurate reading by going slower towards the end point. And we are repeating this until we get concordant results, so results within 0.1 of each other. And for the final activity, can you please complete this table identifying the reasons for each of these actions taken? Thank you all for watching and see you next time.